dear students. In the previous video we discussed the concept of quantum numbers. The quantum numbers give us information about the electron. These are a set of 4 mathematical numbers. And we learned how to calculate quantum numbers. The first quantum number is principal quantum number, which gives information about the shell. The second quantum number is azimuthal quantum number, which gives information about subshell. A shell is further divided into subshells. The third quantum number is magnetic quantum number, and it gives information about the orbital in which the electron is present. And the fourth quantum number is spin quantum number, which gives the orientation of electron, that is whether it is in clockwise or anti-clockwise direction. Now, an orbital is represented by a box or by a small circle. Now, ultimately electrons are found in orbitals only. Your atom is divided into shells. Shells are divided into subshells, and within your subshells your orbitals are there. And in those orbitals the electrons are found. So on paper the orbital is represented like this. One orbital can accommodate only 2 electrons. Okay, so in a single orbital 2 electrons can be located. Now if 2 electrons are together in an orbital, their orientation should be in opposite direction. That is, if one electron is moving in clockwise direction, the another electron is moving in anti-clockwise direction. This arrow represents the spin of electron. So one orbital can accommodate 2 electrons, and if both the electrons are there in the orbital, their spin should be opposite like this. Okay, so this is a way to represent or locate electrons on paper. Now there are certain relations. The first relation is number of subshells in a given shell, that is n, is the shell number itself. Suppose I want to calculate the number of subshells in 10th shell, that will be equal to 10. The second is number of orbitals in a given shell, it is n square. So suppose my shell is 10th, so number of subshell will be 10 only, and what will be the number of orbitals? That is 10 square, that is 100. The number of orbitals in a given subshell L, because a subshell is denoted by L, it is 2L plus 1. And lastly, the number of electrons in a given shell is 2n square. Okay, so these are the direct relations which are quite helpful. Now what we'll be doing, now we have learned the concept of quantum numbers, and now we know that if I want to locate the position of an electron, I require the knowledge of quantum numbers. So let's solve some questions which are based on the concept of quantum numbers first. The first question is, using SPD notations, describe the orbital with following quantum numbers. So I have given you the values of n and L, and with the help of these values we have to designate the orbital, that in which orbital the electron will be located. Now what happens, there is a proper notation which we use, and that is n, L and m. Okay, this is the representation of an orbital, that first n comes, then L comes, and lastly your m comes. Suppose I am having the orbital 2s. So this number 2 indicates the principal quantum number, and this s indicates the azimuthal quantum number. Since for azimuthal quantum number I am using the symbol, I can change it into numbers. I know that when L is 0, it is S. When L is 1, it is P. When L is 2, it is D. And when L is 3, it is F. So likewise we'll be solving the questions. Now n is 1 and L is 0. So first n is there, so I will write it as 1. Now for L is 0, we'll use the symbol S. So what is this orbital? It is 1s. The second is n is 3, so I will write 3 as it is. Now L is 1. L is 1 means it is your 3p. The third is n is 4, so I will write 4 as it is. and for 3 I know it is F. The next is N is 3 and L is 2, so it will be your 3D. Likewise, it will be 2P. Likewise, it will be 4D. So this is how you can change the quantum number set into the corresponding orbital. Now in the next question, we have to see which of the following sets of quantum numbers are not possible. So I am providing you the sets of quantum numbers and you have to tell that this particular set is possible or not. So what we'll do, we'll try to change the 4 numbers into the orbital. Now n is 0. This is not at all possible because your number n starts from 1. It is having the values 1, 2, 3, 4 like this. So the first set is not possible. The second is n is 1. Okay, so it is 1. Now L is 0. If L is 0, m can have 0 values. Yes, because what is the value of m? It is minus L to 0 to plus L. So if L is 0, m can have 0 value. So this orbital will be 1s because for 0 we use s. And spin quantum number is also correct. It can be plus half or minus half. It means this set is possible. The third is n is 2. Okay, 2. Now L is 1. L is 1 means it is P. Now if L is 1, m can have 0 value. And I told you in the previous video that if m is 0, it will be 2pz. And spin quantum number is also plus half. So this set is also possible. The next is n is 3. So I will write here 3. Now L is 2. For L is 2 we use D. Now if L is 2, m can have the value of 0. So if m is 0, in the previous video we learned that it is dz square. And spin quantum number is also correct. So this set is also possible. The last is n is 1, L is 1. Now n and L cannot be equal because what is L? It is 0 to n minus 1. It is always having one value lesser. It means this set is not possible. Now the next question is, an orbital has the value of n equal to 3, means my shell is 3. So n is 3. Now what are the values of L and m? Now L indicates subshell. The value of L is 0 to n minus 1. So if n is 3, so I can have the values of 0, 1 and 2. It means 3 values are possible. If it is 0, it will be 3s, it will be 3p and it will be 3d. Now we have to calculate m. The formula is minus L to 0 to plus L. Okay, and m is calculated individually for the 3 values. So I will calculate for all the 3 values. So if your L is 0, your m will be 0. This is the first value. If your L is 1, it will be minus 1, 0 and plus 1, 3 values. And if it is 2, it will be minus 2, minus 1, 0, plus 1 and plus 2. Now since one value is there, so one orbital is there. This will be 3s. Now 3 values are there, means how many orbitals will be there? 3, 3px, 3py and 3pz. And since 5 values are here, so the number of orbitals will be 5. That is dxy, dyz, dzx, dx square minus y square and dz square. So this is how to solve this question. The next question is, I am providing you the orbital and you have to write the values of 4 quantum numbers. The first orbital is 2px. Now for 2px I told you what is the designation order. It is NLM. This is the way we write the orbital. So n is 2. Now for p, L is always 1. Now what is the value of m? If L is 1, m can have the values of minus 1, 0 and plus 1. But in the previous video we learned that if px or py is there, we can have the value either minus 1 or plus 1. So any value you can write. For pz, the value is 0. And the spin quantum number, it's your choice. You can write plus half or minus half. The second is 3s. Now the first is 3. Now s means L is 0. Now if L is 0, m can have only 0 value. And spin quantum number can be plus half or minus half. Now the third orbital, that is 3d x square minus y square. The first number is 3, that is shell, so it will be 3. Now the next is d, and for d L is always 2. Now it is x square minus y square. And if you remember, in the previous video we learned that for x square minus y square the value can be minus 2 or plus 2. And spin quantum number can be plus half or minus half. Likewise, now here 2pz is there, so it is 2, 1 and 0. The spin quantum number can be any. Now it is 1s, so it is 1, 0, 0, and the spin quantum number can be plus half or minus half. So we have learned that if I give you the set of 4 quantum numbers, you can change that set into the corresponding orbital. And if I give you the orbital, you can change, you can determine the quantum numbers for that particular orbital. Such type of questions are generally asked from this topic. The next question is, how many electrons in a given atom can have the following quantum numbers? So now the first is n is equal to 3 and L equal to 1. So first I will change this quantum number set into the corresponding orbital. What is the sequence? N, L, M. So 3 as it is, and it is P, 3p. Now I know that 3p means it is not the orbital, it is the subshell. Okay, and there are 3 orbitals in the p subshell. So how many total electrons can be accommodated? 6, because one orbital can accommodate 2 electrons. The second is 3 and d, because for L equal to 2 we use d. Now it is subshell, and I know that d subshell has 5 orbitals. So how many electrons can be accommodated? 10 electrons. Now n equal to 2 and L equal to 1 means it is 2p. So again 3 orbitals will be there, so 6 electrons. And last is 2s. Now s means single orbital, so the number of electrons will be 2. So these are the names of subshells. And in a particular subshell we have orbitals. So 3p means it is the subshell, and for p, how many orbitals are there? 3. It is like this: s, p, d, f, 1, 3, 5, 7. These are the number of orbitals present in the particular subshell. So with this, the concept of quantum numbers is over. The entire quantum mechanical model is based on the concept of quantum numbers only. With the help of quantum numbers, we can locate the position of electron in the atom. Your atom is divided into shells determined by principal quantum number. Shells are further divided into subshells determined by azimuthal quantum number, and within the subshells your orbitals are there determined by magnetic quantum number. And the last quantum number shows the orientation of electron, whether it is revolving in clockwise or in anti-clockwise direction. One orbital can accommodate only 2 electrons, one moving in clockwise and one moving in anti-clockwise direction. So this was all about your quantum numbers, and we have solved some questions based on the concept of quantum numbers. Thank you.